Hi, my name is Shehroz Ahmed, and in this video we're going to discuss a topic of statistics, and that is significance test or hypothesis testing. Okay, so in this topic we have to, in order to understand this topic, we have to discuss an example. So let's suppose there are 4 siblings, A, B, C and D. You can say A for Adam, Bill and Catherine and David. So these are the 4 siblings. So they have to wash the dishes. The parents have said to them that one of the siblings have to wash the dishes every night. So what they do is they put their names into a bowl and then pick up the name of any sibling, and the sibling whose name is picked up, his duty is to wash the dishes. So what do they do is, on the first day we will discuss the case of David. If we say that there's an equal chance of all the siblings for their name to come up, all have the same probability. So let's suppose David. The chance that the name of the David will not come is 3/4. So on the first day his name did not come, that's fine. So there's a probability of 0.75 that his name will not come. On the second day again his name does not come, so it'll be like 3/4 times 3/4. Same happens on the third day, same happens on the fourth day. Till fourth day it's fine. So if you find out the probability after the 4 days that his name is not coming, so that will be somehow equal to, let me just calculate it quickly. So that probability is equal to 0.32. that's fine. Now after the 12 nights, let's find out the probability that his name does not come after the 12 nights. So if we do it, then the probability that we will get will be equal to 0.031. that will be approximately equal to 3.32. that will be equal to 3.2%. So now everything, like Adam, Bill and Catherine, have gotten suspicious that why his name is not coming. So I think there's something fishy that's going on. There might be a chance that David has cheated, or the David has not put his name, or maybe he has put any other sibling's name into the bowl. So for that purpose we use the hypothesis testing. So for each hypothesis testing we mark a certain criteria, that if the probability falls falls below a certain percentage, then we will say that our assumption is wrong. So in this case we will say our initial assumption is that the selection is fair. So we can say that this is our assumption: the selection of the sibling is fair, and if the probability or the percentage drops by, let's suppose, 5%, then we will say that the selection is not fair, or there is some cheating going on in the selection. So the selection is not fair in case the percentage drops below 5%. The selection is not fair. So that significance level that we define over here, that defines our hypothesis to be true or false. So that significance level is represented by the alpha, and like in most cases that significance level is 5%. So if the probability if the probability drops below 5%, then we will say that our hypothesis or our initial assumption is wrong. If the probability remains above 5%, then we will say that our assumption was correct. So that concept is called the hypothesis testing. Now in this hypothesis testing we may be correct, or we might be wrong. So we will see the type of errors that we can do in our hypothesis testing that will define us whether we are correct or whether we are incorrect. So for that purpose we have to discuss the concept of type 1 error and the type 2 error. But before that I want to explain you the concept of the null hypothesis and the alternative hypothesis. So the initial assumption that we have taken that says that selection is fair, so that will be considered as the null hypothesis. We can mark it with HO. So it's the null hypothesis which says that the selection is fair, and the alternative hypothesis is that the selection is not fair. So if our probability or the percentage remains above 5%, we will say that our null hypothesis is true. If the probability falls below 5%, then we will say our alternative hypothesis is true. In that case, we will reject our null hypothesis and accept our alternative hypothesis. So this H naught is basically the null hypothesis, and HA is called the alternative hypothesis. So now we will discuss what are the errors that can cause. So we have to discuss what are the errors that can come across when we have to deal with the null hypothesis and the alternative hypothesis. So let's start off with that. So the errors in hypothesis testing. So there are two types of error in hypothesis testing, and they are called the type 1 error and the type 2 error. So for that purpose, I'll just draw a table over here, and from this table I will explain you what will be our type 1 error and what will be our type 2 error. Okay, so I'll just divide this table into 4 boxes. So we have written two hypotheses, null hypothesis and the alternative hypothesis. So the null hypothesis was that the selection is fair. The selection is fair, and the alternative hypothesis was the selection is unfair. Is unfair. So if in actual the selection is fair, which means in actual our null is true, and we accept our null hypothesis. Let's suppose we accept our null hypothesis. I'll just write over here, accept null. Then we have made a correct decision. All right, in actual the null hypothesis was true and we have accepted our null hypothesis, then our selection is true. Now in actual, when in actual the null hypothesis was true, but the percentage came below the significance level and we have to reject the null hypothesis. So reject null. In that case, our decision is incorrect. So we have made a type 1 error. Type 1 error. The actual value was true, but according to our significance level that we have set, our percentage is less than 5%. So due to that we had to reject our null hypothesis. So in that case we have made a wrong decision. Okay, now let's see another scenario. Let's suppose in actual our value is false. Our null hypothesis is false, which means the selection was not fair, but our percentage became let's suppose 10% or 12%, that was above 5%. So we could not reject the null hypothesis and we had accepted the null hypothesis. So in that case our decision is again wrong, because in actual null hypothesis was false, but we have accepted the null hypothesis based on the percentage that we got as the answer. So this type of error is called type 2 error. Okay, now if our hypothesis was false, which means the selection was not fair, and we had rejected the null hypothesis, which was that the selection is fair, and we had accepted the alternative hypothesis that the selection is unfair, in that case our decision is correct. So we have made a correct decision. So if our actual value is true but we reject the null hypothesis, it means it gives us the type 1 error. But in actual, if our null hypothesis is false but we accept the null hypothesis, then it's a type 2 error. So these are very important that you have to understand in the hypothesis testing. So it has a direct relationship with the significance level. So for the type 1 error, if our significance level is, let's suppose, 1% instead of 5%, and our answer is 3%, so in that case we would avoid the type 1 error. But in type 2, let's suppose the actual value was false, but we had to accept the null hypothesis because the significance level was low. So let's suppose the answer was 7% and our significance level was 5%. So if we could increase our significance level to 10%, then we could avoid the type 2 error. So in other words, if we reduce the significance level, then we can avoid type 1 error. But if we increase the significance level, we can avoid type 2 error. But with the increase in the significance level, we can avoid the type 2 error, but we are more likely to make type 1 error. And with the decrease in the significance level, we are more likely to make type 2 error. So there's a rift between type 1 error and the type 2 error. So that's why we use a standard, in most cases a standard significance level is used, and that is 5%. All right, so now we will discuss the next thing, and that is calculating the z-statistics, and with the help of the z-statistics, how we can find out the probability, and by finding out the probability we can accept or reject our null hypothesis. All right, so z-statistics. So z-statistics gives us a constant value depending on some of the data. So let's suppose we have to find out the probability of the people who have the car in the whole population. So but we are not able to find out the we are not able to collect all the data from the population, and it takes a lot of time, and in that time the data might get changed. So what we do is, from the whole population, let's suppose this is the whole population, we take the data of a group of population that is convenient, that is easy, and that could represent the whole population. So the probability of the whole population, we represent it with by, let's suppose, this symbol mu, and the probability of this sample is represented by another symbol, and that is, let's suppose, probability of the sample, p of s. So by comparing the probability of the sample with the probability of the population, we have to use a constant, and that constant is called the z-statistics. All right, and we will calculate this constant. By the help of this constant, we basically trying to determine the probability of the whole population who owns the cars by seeing only the sample. So once we get this constant, then we will use a z table, and from that table we will be able to work out the probability. That probability will not be exact, so for that purpose we will use our significance level. In most cases it is 5%. So we can predict, we can go as much close to the answer, but in that this will not be the accurate answer. Anyway, so let's start off with the calculation of the z-statistics. So we can calculate the z-statistics by this formula. So z is equal to the population of the sample minus the probability of the sample minus the probability of the population divided by, I'll just write the probability as simple p. This is the probability of the whole population, this is the probability of the sample, whole divided by probability of the population minus 1 minus probability of the population. I'll just write p and p over here, divided by n. N are the total people in the sample. So from here we will get a z value. Now from this z value we'll be able to find out the probability, but if we have a normal distribution, and the z value will be represented over here. Okay, so let me just write on the significance level. So let's suppose this this blue region is representing our significance level. So if our z value lies in this blue region, then we have to reject the null hypothesis. If our z value does not lie in this blue region, then we have to accept the null hypothesis. So for example, in the middle we have 5 as the mean, and our z value is something like 7.7. So as you can see, this z value is outside this blue region, so we have to accept the null hypothesis. If our z value is somewhere over here, then we have to reject the null hypothesis. So this is how we can see the z statistics, and by looking at the z statistics we can work out we can reject or accept our null hypothesis. So we will look for more in detail once we go through the examples. So let's start off with examples now. All right, so here we have an example. In this example, it says Alessandra designed an experiment where subjects tested water from 4 different cups and attempted to identify which cup contained bottled water. Each subject was given 3 cups that contained regular tap water and 1 cup that contained bottled water. She wanted to test if the subject could do better than simply guessing when identifying the bottled water. Her hypotheses were H naught, that is the null hypothesis, that the probability is equal to 0.25, versus the alternative that p is greater than 0.25, where p is the true likelihood of these subjects identifying the bottled water. Okay, the experiment showed that 20 of the 60 subjects correctly identified the bottled water. Alessandra calculated the statistic probability, that is equal to 0.3, had an associated p-value of approximately 0.068. So according to this statistic, she got the p-value to be 0.068. that will be around 6.8%. Okay, now what conclusion should be made using a significance level of 0.05? Now as you can see over here, the p-value that she got is greater than the significance level. So if our p-value is greater than the significance level, then we cannot reject the null hypothesis. So for this one, we will say that we cannot reject the null hypothesis. So let's see the options. So the option is fail to reject null, and accept alternative hypothesis, accept null hypothesis. So we will not say that accept the null hypothesis. We will say that we are failed to reject the null hypothesis. So that would be option A, and that's correct. Okay, now the next one, it says in context, what does this conclusion say? Okay, so for this one, the options that we have are: number 1, the evidence suggests that these subjects can do better than guessing when identifying the bottled water. No, it's not true. It was in the alternative hypothesis that the subjects can do better in guessing. The next is, we do not have enough evidence to say that these subjects can do better than guessing when identifying the bottled water. So this is true because we literally do not have any evidence. C, it says the evidence suggests that these subjects were simply guessing when identifying the bottled water. So there's no proof that they're just simply guessing. So because we have accepted, like we had failed to reject the null hypothesis based on the p-value, so we will say that we do not have enough evidence. And let's check, and that's right. Okay, now the next one, it says how would the conclusion have changed if Alessandra had instead used a significance level of 0.1? So I think there will not be any impact. Let me check. Yeah, so I think she would have reached the same conclusion using either 0.05 or 0.1. No, in 0.1. Okay, in 0.1 because 0.06 is less than 0.1. It is less than 0.1. So in this way, in this one, she had to reject the null hypothesis and accept the alternative hypothesis. So it should be C, and that's correct because the significance level is the p-value is less than the significance level. So when this happens, we have to reject the null hypothesis and accept the alternative hypothesis. All right, so this is it for this topic, and I hope you got the concept of the hypothesis testing, the significance, the concept of significance level, type 1 error, type 2 error, and somehow the z statistics. So thanks a lot for watching the video, and thank you.